So this is lesson number, there we go. And this is over the distance formula and the relationship of PV equals nRT. Alright, so the distance formula, we're going to use Pythagorean. So you remember old Pythagorean, old Pythagoras, a squared plus b squared equals c squared. We're going to use the same kind of a concept here, because what we're looking for is the length of that line. Now if you notice, I can make this into a right triangle, and I will always want to do that. And if I can find the length that is from here to here and from here to here. Alright, so the length, my up and down, or my y length, is 1, 2, 3, 4, 5, 6, 7. And the length of my base here is 1, 2, 3, 4, 5, 6. So to find this length here, I just have to take a squared plus b squared equals c squared. So 49 and 36 is 85. Take the square root of both sides, and I get c equals the square root of 85, which is somewhere around 9. A little bit bigger than 9. And that's the length of that. Okay. I want to teach you how to do this without always having a graph there to look at. Alright, so let's erase all of this, and let's look at what we've got, especially considering the last lesson that we did, lesson number 87, where we were using the slope formula. Remember, the slope formula was y2 minus y1 over x2 minus x1. Okay, so what we're going to do is we are going to find out the change in y and the change in x. Now, this is the cool thing about this, is the change in y will be this distance. The change in x, then, will be this distance. Okay, so let's take the change in y. Change in y will be the y portion of the top point minus the y portion in the bottom point, 7. Now if you count these from here to here, you'll see that we went down 7. So my y value is 7, and then my change in x will be whatever this is minus whatever this is, equals negative 6. Alright, so one of the things that you've learned is, let's see, negative 2, negative 2 minus 4. One of the things you've learned is distances are always positive. So what we'll do is we'll take, whenever we get a negative for a distance, we'll take the absolute value of it so that we get a 6. Because you'll notice that the distance between here and here is going to be 1, 2, 3, 4, 5, 6. Alright, so even if you end up with a negative here, just change it to a positive to show a length here. Now we could use our Pythagorean. 6 squared plus 7 squared equals our hypotenuse squared, or the square root of 85 like we got earlier, which leads us to the distance formula. A squared plus b squared equals c squared. Now, how did we find our distance here of x? Okay, let's say that that's our a squared, or our a, and this is our b. How did we find our a? We took one of the x values and subtracted the other x value. Okay, so we took that, and then we squared it. Okay, so we took the difference between our x's and squared it. Then how did we find our y value? We took the distance between our y's and squared it, and that was our b. And then there's an addition sign right there, and that equals our hypotenuse squared, or our distance that we're looking for squared. Okay? So we're coming up, whoops, come on. We're coming up with the formula right now is what we're doing. Alright, so we've got that. Then what do? We take the square root of both sides, and that gives us just a d then. So distance equals x sorry, I'm not talking now. Okay, there's our distance formula. So we came up with a formula that will always work when we're finding the distance between 2 points. So let's keep that in mind when we do some of these problems here. So I'm going to get rid of everything except this distance formula. Okay, there's the distance formula. So let's look at example 88.1. And we're only going to do one example. This really isn't too bad. I don't think you'll need lots of practice with this. But I have 2 points. And I want to find out what the distance is, the numerical distance between the two. I'm going to use this formula. So I'm going to rewrite this and substitute x's. So I'm going to use my x2. So I'm going to use this 4 as my x2 minus this negative 5 as my x1. And then I'm going to use this negative 2 as my y2 minus 3 as my y1. And I got to square both of these. So d equals the square root of 4 plus 5 is 9. Negative 2 minus 3 is negative 5. And we square that. So d equals the square root of 81 plus 25. So my distance equals the square root of 106. Now I cannot reduce 106. If I had an answer of 100, you could take the square root of 100 and get 10. If I had the square root of, let's say, 108, I could reduce that, simplify that, by doing 254 2 times 25, 26, 27, 3, 9, 3, 3. So I would have my distance, if I had a square root of 108 for an answer, then I could write this as the square root of 2 squared times 3 cubed. All right, I'm just showing you a what if, just to remind you of how to simplify these radicals. So d equals, if I have my index of 2, 2 goes into 2 one time, so I can bring a 2 out. 2 goes into 3 one time, so I can bring a 3 out, but I have 1 left over, so I leave it in there. So the square root of 108 is 6 times the square root of 3. So rather than leaving the square root of 108, I would want you to reduce it to 6 square root of 3. But square root of 106 doesn't reduce, so that's all you have to do. Alright, that is it for lesson number 88 for the distance formula. Let's move on to this next section. Oops. And the next section is PV equals nRT. Okay, these are not too bad. This is chemistry, and you'll get this in a lot more detail later. Okay, so here we go. I would write down this formula here and put it in your notes for lesson 88 because you will need that. Here is the formula that we're going to look at. P is the pressure in atmospheres. Remember, it's atmospheres. They will always give it to you in atmospheres rather than in cubic, pounds per or foot-pounds or something like that. The V is in volumes and liters, liters only. So if they give it in something else, you're going to have to change it to liters, but I don't think they will in this one. This is number of moles of gas. This is a constant. It will always be 0.0821, so you don't have to worry about coming up with a number there. It will always be this number. Temperature is in kelvins. It's not in Fahrenheit, it's not in Celsius, but I don't think you'll have to worry about that either. Alright, so 88.2. Use the relationship PV equals nRT to find the number of moles in an amount of gas when the temperature is 200 da 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 da. So what we're looking for is we're looking for this answer right here. So what I suggest doing before you do anything is take this and change it, set it equal to n. So in order to set that equal to n, we're going to divide both sides by RT. And that cancels my RT. So I get n equals PV over RT. Now I just plug numbers in. It says that the pressure is 1. It says the volume is 8. It says my R value is 0.0821. Remember, that's constant. That's always going to be that. And my temperature is 273. And I just solve for n. That is it. Alright, if we look at the next one, example 88.3. Let's look and see what they've got there. We are looking for the volume. So we're trying to find the volume here. So we're going to divide both sides by P. So we get V equals nRT over P. And we just, again, plug things in. 0.832 for our N. Our R is again 0.0821. And our temperature is 400 kelvins. And we are over pressure of 3 and solve. Okay, multiply these 3 and divide by 3 and you should get 9.11. And that is it for PV equals nRT. Not really a whole lot of it. I think you'll just kind of be like, oh, this is kind of fun. Math when it's kind of easy is not too bad. So anyway, that's lesson number 88.